AC applied to the pure resistor, that already we studied. Now we look into another important point, that is AC applied to the pure inductor. I said 3 components: resistor, inductor and capacitor. So now the study is AC when applied to the inductor, what happens? AC applied to the pure inductor or ideal inductor, you can say like that. Now, it is the inductor of self inductance L connected to the AC source. Already said earlier, we start with the voltage and we derive the formula for current. So, what is the equation for voltage? V is equal to V naught sin omega t. It is the equation for voltage. From this, we derive the formula for current. Once you connect inductor to the AC source, because of the alternating voltage, you have got a current I. And I want to derive the formula for I. I is the instantaneous current. But one thing is very clear, as voltage changes, current also changes. So that is obvious, remember. For the alternating voltage, current must be changing with time. And whenever current through the inductor changes, an EMF is induced across the inductor. Therefore, here you have got a induced EMF, let it be E. E is the induced EMF, not elementary charge. Be careful in this discussion. And we know what is the formula for E. E is given by the equation minus L di by dt. What is di by dt? Di by dt is the rate of change of current. This instantaneous value changes, its rate of change of current is di by dt. Okay. Now, in this circuit there are two EMFs, one is applied voltage V, another one is induced EMF, and now we apply Kirchhoff's voltage law. According to Kirchhoff's voltage law, what is the Kirchhoff's voltage law? That already we know, that is sigma EMF is equal to sigma IR. Algebraic sum of EMFs is equal to algebraic sum of product of current and resistance in a circuit. How to find out algebraic sum of EMFs? One is applied voltage V plus induced EMF E, two EMFs V plus E is equal to, is there any resistance here? AC applied to the pure inductor or ideal inductor, therefore what is the resistance? 0. Therefore in this circuit R is 0, therefore right hand side term is 0, or V is equal to minus E. Applied voltage is equal to induced EMF, but they oppose each other. Okay. Now V is nothing but V naught sin omega t is equal to minus, what is E? Minus L di by dt. Minus minus becomes plus. Okay. Now I want to write the equation for di, rate of change in the external current, means this current I is changing, that is its change is di. What is the formula for di? Di is equal to, it is V naught sin omega t into dt divided by L. L comes to denominator. Now we know right side term is left hand side term is di. The integration of di is nothing but I. Therefore, we integrate this equation, then we get the equation for current I. So, next step, integration di is equal to integration V naught by L into sin omega t dt. Integration of di is I. V naught by L constant, take it outside, and what is remaining? Integration of sin omega t dt. But integration of sin omega t is minus cos omega t by omega plus c, integration constant, plus c. Now, first of all, we try to find out integration constant c. What is the value of c? Now, in this discussion, integration constant c is equal to 0. What is the reason to say integration value is 0? Think that integration value is non-zero. Let us say c is equal to 4, let us say. What is that 4? Okay, you write 4 here. Look at the left hand side, I, current. Current is equal to this value plus 4. Is it not 4 ampere? We can't write only 4. It must be what? 4 ampere, because left hand side and right hand side unit must be same. Left hand side is current. Therefore, if C equal to 4, it is what? 4 ampere. Is it not a DC? It is a constant value, means what? DC. Is it possible? Because what we are discussing is AC, not DC. Therefore, integration constant value is always 0. Therefore, C equal to 0. Straight away we write C equal to 0 and we simplify the remaining part. Therefore, I is equal to, now take omega outside, V naught L omega into minus cos omega t. Look at these 3 terms here: peak voltage, self inductance of the coil, angular frequency of AC. All of them are constants, and all of them are constant. We can reduce it to a single constant, that is I is equal to I naught into minus cos omega t, where I naught is equal to V naught by L omega, known as peak current. Peak current. Now, this is the equation for current. But if you look here, it is the equation for voltage. It is in sine function. This is in cos function. Therefore, it is not convenient. It is better to change this cos function to again sine function. So, we will rewrite it. That is I is equal to, it is I naught into minus sine pi by 2 minus omega t. Because we know sine 90 minus theta is cos theta. This minus sign as it is. Okay. Now, it is the sine function, therefore, we can take minus sign inside. If you take minus sign inside, then I is equal to I naught into sine, minus sign is inside, it is omega t minus pi by 2. It is the equation for current. So, let us say equation 2. Now, equation 1 represents voltage, equation 2 represents current. So, very clear, both of them are sinusoidal. This is also sine, that is also sine. But what is the main difference? Here it is omega t, and here it is omega t minus pi by 2, means they have got a different phase angle. They have got different phase angles. And which one is having the higher phase angle? Definitely voltage is having higher phase angle, because if it is omega t, there it is omega t minus pi by 2, 90 degree. Therefore, that is the smaller phase angle, voltage has got higher phase angle. Therefore, now which one is leading? V leads I. By how much? So, we find out phase difference. So, phase difference is nothing but it is a omega t minus omega t minus pi by 2. Phase angle of voltage minus phase angle of current. Omega t cancels, minus minus plus. Therefore, it is pi by 2 radian. Therefore, what is the phase angle or phase difference? Not phase angle, phase difference. Phase difference is pi by 2 radians. And who is leading? V leads I. By how much? Pi by 2 radians. Can we explain this one in another way? Definitely. If you want to explain this one in another way, then you have to say I lags V by pi by 2 radians. I lags V by pi by 2 radians. Okay. Now, next step, we go for graphical representation. We plot the graph of voltage, and then we plot the graph of current, and later we draw phasor diagram for that. Now, this is the equation for voltage, it is the equation for current, omega t minus pi by 2. Now, how to plot the graph? So, first of all, we plot the graph of voltage, because it is the standard one. So, plot the graph of voltage. This is the graph of voltage, and in the same graph we plot current also. Okay. Now, see, we discuss in detail how to plot the graph. So, now I am taking time equal to 0. I am taking time equal to 0, means it is the starting point here. When time equal to 0, what is the voltage? 0. So, we simplify this one. V is equal to V naught into sine omega t is 0, that is 0. Like that, current I is equal to I naught sine omega t 0 minus pi by 2. That is I is equal to, this is sine minus 90 degree, minus can be taken outside, sine 90 is 1, therefore it is minus I naught. So, when the time equal to 0, voltage is 0, but current is minus I naught. So, that we plot here. So, this is the time equal to 0, voltage is 0, current is minus I naught, let it be here. Next, take t equal to t by 4, that is this point. When time equal to 1/4 of the time period, what is the voltage? V is equal to V naught sine omega. Omega can be written as 2 pi by t into t by 4, omega t. this we can cancel, and this is actually pi by 2, sin pi by 2, sin 90 degree, sin 90 degree is 1, therefore, it is V naught, V naught. And what is the current? I is equal to, it is I naught sin omega t, that is 2 pi by t into t by 4 minus pi by 2. So, this is 90 degree, remember, because t we can cancel, it is 2 pi by 4, that is pi by 2. Pi by 2 minus pi by 2, 90 degree minus 90 degree, that is 0, sin 0 is 0, therefore, current equal to 0. Means when time equal to t by 4, voltage is V naught, but current is 0. So, when time equal to t by 4, voltage is V naught, but current is 0, 0 means here. So, first point is here, second point is here, t by 4. Now, we take third point. Take t is equal to t by 2, half of the time period. V is equal to V naught sin 2 pi by t into t by 2. This t we can cancel, 2 also we can cancel. So, sin pi, sin 180, sin 180 is 0, therefore, V equal to 0. And what about current? I is equal to I naught sin 2 pi by t into t by 2 minus pi by 2. So, t cancels out, 2 cancels out, it is pi minus pi by 2. Pi means 180 degree, 180 degree minus 90 degree, sin 90, sin 90 is 1, therefore, I is equal to I naught. Means, when time equal to t by 2, voltage is 0. Look here, voltage is 0, voltage is already 0. But what is the value of current? Current is equal to plus I naught. So, to take the same value I naught here, plus I naught. Now, we take next point, fourth point. Take t is equal to 3t by 4, this point, 3t by 4. What is the voltage? V is equal to V naught sin 2 pi by t into 3t by 4. Okay. T we can cancel, and this is 2 times. So, look here, it is 3 pi by 2, 3 pi by 2, pi by 2 is 90 degree, it is 3 times, means 270 degree, sin 270 is minus 1, therefore, V is equal to minus V naught, V is equal to minus V naught, that is here, V is equal to minus V naught. What about current? Now, we find out current. Current is given by I is equal to I naught sin 2 pi by t into 3t by 4 minus pi by 2. So, this value already said it is 270 degree, this value. 270 degree minus 90 degree, that is 180, sin 180 is 0, therefore, current is 0. So, when voltage is a negative maximum, current is 0, the point is here. So, we are getting different points like this, 1, 2, 3, 4. The graph goes like this. Now, last point, when t equal to capital T. So, fifth point, take t is equal to capital T, time period, V is equal to V naught sin 2 pi by t into t. T we can cancel, it is a sin 360, sin 360 is 0. Therefore, voltage is 0. Current I naught sin 2 pi by t into t minus pi by 2. T we can cancel. So, it is 360 degree minus 90 degree, 270. 270 means sin 270 minus 1. Therefore, minus I naught. Therefore, when time equal to capital T, voltage is 0, but current is negative maximum. So, here minus I naught. Now, we join all these dots. It is the graph of current. So, it goes like this. It is the graph of current. It is the graph of voltage. So, it is the way to plot the graph, and in exam this part is not required, only this graph is required. If they ask, only give the graph, no need of writing all the points here. Next step is to draw phasor diagram. How to draw the phasor diagram for voltage and current? V is equal to V naught sin omega t. It is voltage. So, we draw phasor diagram for voltage. V is equal to V naught sin omega t. This is omega t. What about current? For the current, the equation is like this. I is equal to I naught sin omega t minus pi by 2. So, look here, whenever we measure the angle in the anti-clockwise direction, it is positive, that already know. If you measure the angle clockwise, it is negative. Therefore, look here, omega t minus pi by 2. So, from here up to here omega t minus pi by 2 means from here 90 degree clockwise, 90 degree clockwise. So, omega t positive minus 90 degree down by how much? 90 degree, from here 90 degree. Therefore, the current in the phasor drawing, current comes in this quadrant. This angle is 90 degree. So, omega t minus 90 degree, from here 90 degree down. So, this is the phasor drawing of current and voltage, and both of them are rotating in which direction? Anti-clockwise direction. Now, if you take V naught, we find out its y component. That is, what is the phase angle for voltage? Omega t. Therefore, it is V naught sin omega t. It is nothing but instantaneous voltage. Look here, V naught, its y component is V naught sin omega t, that is instantaneous voltage. Like that, current is here, I naught. I want to find out its instantaneous value, y component. Now, what about phase angle of the current? Omega t minus Therefore, it is I naught into sin omega t minus pi by 2. Is it not I? Yes, instantaneous current. So, I is equal to I naught sin omega t minus pi by 2. This is the phasor drawing of voltage and current in the case of pure inductor or ideal inductor. Okay. Now, can we link both of them? Because it is the graphical representation and it is the phasor diagram. So, how to link both of them? So, we try to plot both of them side by side. First of all, you take voltage. Actually, you have to measure this one. Rough measurement is enough. So, this much. V naught. It is omega t, and this is representing current, but current is 90 degree behind, therefore, it comes here 90 degree. I naught. This is instantaneous voltage V, and I want to take this one to the graph. V. Then corresponding current is I. So, now these are the instantaneous value at the time t that is represented here, and from the graph it is very clear, as the time increases, now voltage increases, current value decreases to 0. So, this is graphical representation and phasor diagram. In the earlier discussion, we took I naught is equal to V naught L omega, where L is the self inductance, omega is the angular frequency of AC. Now, you compare this formula with the Ohm's law, R equal to V by I. I is equal to V by R. Just for comparison, look here, this is current, this is also current, it is voltage, this is also voltage. Here it is resistance of the conductor, denominator, and here you have got L omega. Therefore, L omega can be taken as resistance of the inductor. So, just by comparison, we can write it as I naught is equal to V naught by R, but resistance of what? Inductor. So, R suffix L. But once you write like this, just by comparison, it becomes resistance of the inductor, but we have got one problem here. What is this? In this formula, it is resistance, it is given by Ohm's law. This resistance has got two properties. One, it opposes the current. Second, it consumes energy and produces heating effect. It consumes electrical energy thereby it produces heat. So, if you write L omega as the resistance of inductor, then you have got a problem. It opposes the alternating current, but inductor never use any electrical energy, thereby it cannot produce any heating effect. So, here resistance has got two properties, one is opposing, another one is consuming energy and producing heating effect. But here you have got only one property, what is that? Opposing. It opposes the current, but pure inductor cannot produce any heating effect. Therefore, we can't say that it is resistance. If you use the word resistance, it is confusing, hence we change the term, it is known as reactance. It is known as what? Reactance. And what is the symbol for reactance? Symbol for reactance is X. Therefore, it is written as XL. Reactance of the inductor or inductive reactance. So, by comparison, inductive reactance. Just by comparison, X suffix L is equal to omega L or L omega, anything. Now, rewrite this equation. Inductive reactance XL is equal to V naught by I naught. Therefore, inductive reactance can be defined as the ratio of peak voltage across the inductor to the peak current through it. It is the definition of inductive reactance. Okay. But in AC, generally we deal with the RMS value. RMS value is the general value. RMS value is always a general value. For example, what is the household supply of AC? 220 volts, we know. In some of the foreign countries, it is 110 volts. But what is that value? RMS value. Therefore, RMS value is always known as general value of AC. Therefore, even though it is the definition of inductive reactance, it is better to explain or define in terms of RMS value. How to do that one? See here, V naught by I naught. This. What I will do for the numerator and denominator, I will divide it by root 2. V naught by root 2. This is I naught by root 2. But what is V naught by root 2? V naught by root 2 is Vrms. I naught by root 2 is IRMS. Therefore, V naught by I naught is also equal to Vrms by IRMS. This is one thing. Like that we will take one more equation. V naught by I naught. Here you multiply by 2 by pi numerator. Denominator also 2 by pi into I naught. It is not making any difference. Both numerator and denominator multiplied by 2 by pi, 2 by pi. But what is this value? Mean value of AC. This is mean value of current. Therefore, V naught by I naught is also equal to Vrms by IRMS is also equal to Vm by Im. So, inductive reactance, we can find out inductive reactance by solving any one of them out of three. V naught by I naught equal to Vrms by IRMS is equal to Vm by Im. But to define, it is better to take this equation. Therefore, how to define inductive reactance? Inductive reactance is defined as the ratio of RMS voltage across the inductor to the RMS current through it. This definition is better. Okay? Now, what is the meaning of inductive reactance? Yes, this is what I said is a definition. But in exam they may ask, what is the inductive reactance? Inductive reactance is the opposition offered by the inductor for the flow of AC. Don't use the word resistance, because resistance means this. It has got two properties, opposing and producing heating effect. but here it opposes, but it never produces heating effect, that we prove. Next step you have to study why inductor cannot produce heating effect. Up to that just remember enough. So, inductive reactance is the opposition offered by the inductor for the flow of AC, and do not use the word resistance, that is wrong. Okay. This is definition. Now, it is the ratio of voltage and current, therefore, it is expressed in terms of ohms. Ohm is the unit of inductive reactance because it is the ratio of voltage to current. Okay. Now, we have got one more equation for inductive reactance from the theory, that is XL is equal to omega L, this. What is omega? Angular frequency of AC, that can be written as 2 pi f into L, where f is the frequency of AC. Therefore, it is very clear 2 pi is a constant, self inductance is a constant, inductive reactance is proportional to frequency of AC. As the frequency of AC changes, inductive reactance or opposition of the inductor also changes. Now, take f is equal to 0, frequency of the AC is 0. What is XL? 0. So, if frequency of AC is 0, inductive reactance or opposition of the inductor is also 0. But what is the meaning of frequency is 0? Frequency 0 means, what about time period? Time period is infinity. What is the meaning of time period is infinity? Means AC completes one cycle of variation after infinite time, means it never changes the polarity. Did you got my point? Frequency 0 means a time period is infinity, means after infinite time AC completes one cycle of variation, means it never changes the polarity. What is the meaning of it never changes the polarity? Positive is always positive, negative is always negative, it never changes. Therefore, it is DC, remember, direct current. Therefore, for DC, inductive reactance is 0. For AC, as the frequency increases, inductive reactance also increases. Therefore, plot the graph. Here, we take frequency of AC, and here along y axis we take inductive reactance. When frequency is 0, inductive reactance is 0, that is origin. And as frequency increases, inductive reactance linearly increases. This is the graph. And in annual exam, you can expect this graph for 1 mark. Give the graphical representation of variation of inductive reactance with the frequency of AC. Just to plot this graph, do not explain anything, but you mention x axis and y axis. What are the values taken along x axis and y axis? Okay, we start with the next discussion. AC applied to the pure capacitor. This is a capacitor of capacitance C. It is connected to AC source such that voltage is given by the formula V naught sin omega t. It is the equation for voltage. Let us say equation 1. And look here, as the time changes, voltage also changes. Not only change in the value, even polarity also changes. What is the meaning of that? Let us say at one instant, this side is positive, then this is what? Negative. Think like that. Therefore, this plate acquires positive charge and this plate acquires negative charge. But it is AC, therefore, polarity it has to change. Therefore, after some time this becomes negative, this becomes positive. Then first plate acquires negative charge and this plate acquires positive charge. Means what? It is very clear. As voltage changes, amount of charge in the capacitor changes. Not only amount of charge changing, its polarity also changes. Therefore, electrons are continuously moving through the circuit because it is only due to the flow of electrons. For example, under this situation, electrons are taken from the second plate to first plate. After some time, this becomes a plus, this becomes a minus, electrons they go in the opposite way. So, electrons are in the continuous flow, that is nothing but current. Therefore, you have got a current in the circuit. And what is the equation for current? That we do not know. So, we try to derive the formula for equation for the current, and do not mark this plus minus because it continuously changes, it is AC. Therefore, for timing this may be negatively charged, this may be positively charged, but after some time polarity changes. Therefore, do not write plus minus. But this instantaneous voltage will appear here, no doubt. V is the instantaneous voltage and C is the capacitance. For this instantaneous voltage, you have got a instantaneous charge. That instantaneous charge is given by the formula CV. This is instantaneous charge is equal to capacitance multiplied by instantaneous voltage, or Q equal to C. What is V? V naught sin omega t. But this instantaneous charge is also changing because it is a function of time. Therefore, now we differentiate both the sides with respect to time. So, differentiate, that is dq by dt is equal to d by dt of C V naught sin omega t. dq by dt is, we know it is instantaneous current. dq by dt is nothing but current, rate of flow of charge, instantaneous current I is equal to differentiation. C is a constant, take it outside, V naught is a constant, take it outside. What is remaining? Differentiation of sin omega t. Sin omega t becomes cos omega t after differentiation into omega. That is I is equal to C into omega into V naught into cos omega t. Look here, all the three terms are constants. C is a constant, angular frequency is a constant, V naught is also constant, all of them are constant. So, we can take it as a one constant, that is I naught into cos omega t, where I naught C omega V naught is known as a peak current. So, it is the equation for voltage and actually it is the equation for current, but one of them is sine function, another one is cos. So, it is better to change that cos function to sine function. So, how to change it? It is I is equal to I naught sine omega t plus pi by. We know sine 90 plus theta is equal to cos theta. Sine 90 degree plus omega t is equal to cos omega t. So, it is the equation for current. Equation 2. Now, observe 1 and 2. Equation 1 represents voltage. Equation 2 represents current, both of them are sinusoidal, alternating. But what is the phase angle here? Omega t. What about phase angle here? Omega t plus pi by 2. Therefore, which quantity having the higher phase angle? That is the current. Hence, we say current leads the voltage. Current leads the voltage. I leads V. By how much? By, what is the phase difference between them? It is omega t plus pi by 2. This is just omega t. Therefore, phase difference is 90 degree. Therefore, I leads V by 90 degree or pi by 2 radians. What is the another way to explain? We can say V lags I by 90. So, both the statements are correct. I leads V by 90 degree or V lags I by 90 degree. So, this is the equation for voltage and it is the expression for current when AC applied to the pure capacitor.